So what we're going to do here today, to kick things off, to get started, is we're going to start just, and it might seem real basic and simple, and that's because it probably is, but we're going to start off kind of just introducing some basic geometry vocabulary so that we were all working at the same page, on the same page when it comes to things, right? You maybe heard, the words point before, or line, or plane, or segment, or angle and stuff like that. And you maybe have like a kind of an idea about them, but to really define what those things are and to understand them from a geometry standpoint, then is a little bit different maybe from what you think it is. Okay, so we're gonna start with that. Okay, and the first thing I'd like to look at actually is kind of give you an overview of maybe kind of a bigger picture of how this class will kind of operate. Okay, so let me get you started on that here. So we'll call this maybe like the basics here. Okay. Oh, this pen looks like it's dying. Okay. So, first of all, the first name or thing I want to mention here is a Greek mathematician by the name of Euclid. That's how you pronounce that, Euclid. E-U-C-L-I-D. I know it looks like you did. I don't know Okay, Euclid. So he is the father of our geometry that we're going to be studying. Okay. He's the one that kind of formalized kind of what you would maybe call like abstract geometry, right? I mean, certainly before Euclid, there were people that like named shapes and maybe used properties of shapes and stuff like that too, and things like that. But Euclid was the first one to kind of create like a mathematical system to like define and study geometry. Okay, and so as a result, we are studying is known as Euclidean geometry. Okay, he set out 5 principles. His book, The Elements. Okay, the Elements. So 5 kind of like basic principles that he then used to kind of define all of geometry as you know it. Okay, there's actually other kinds of geometry that are different and maybe like are a little bit weird and funky. Those might be like spherical geometry, so geometry on a sphere, and then hyperbolic geometry, which I can't describe very well beyond the fact that it's called hyperbolic geometry. I used to learn it like one time back in college and stuff like that. But we're going to focus on Euclidean geometry, and I'll talk about those other geometries a little bit later. They have some interesting properties and stuff that you're going to like. That might twist your brain a little, but we'll start with Euclidean geometry. That's what's most familiar. Okay, and this geometry that he has, again, he based it on a system of logic. Okay, and so the way this kind of works is he started with kind of what you might call undefined terms. Some basic terms. Okay, basic undefined terms. Okay. And those basic terms would be like a point, a line, and a plane. Okay. And I think the idea about why they call these things kind of undefined terms, it's not so much that we can't write a definition, it's just that writing a definition is not as easy as you might think, right? A point, you're like, oh, a point, it's a dot. Okay. Okay, but what makes a dot a dot? How do you mathematically kind of define that thing? Same thing with a line, right? A line, like how do you define that kind of thing? We could draw one and say that's a line, right? Like makes a line, right? Same thing with a plane too, okay? So we have the undefined terms. And we'll do our best to kind of give, not necessarily a definition, but like properties of those things maybe. But okay. And then from these undefined terms, we kind of he developed kind of 2 different things. One kind of building block of geometry would be definition, or the group, definitions, right? And we know what a definition is, right? You've done that in English class and stuff like that, okay? Definitions, right? Those are basically just like words. Okay, or terms, if you want to do it that way. In this case, we'll say, in this case, our purposes, we'll say it's a statement that defines a mathematical, or that describes a mathematical object. Okay, and so we'll be looking at some definitions here in just a second. Again, just to have those base kind of understanding. Stuff you probably have heard about before, but we want to make sure we're on the same page when it comes to those ideas. Okay, and then another thing that was developed besides definitions, simultaneously alongside those, are these things called postulates. Okay, geometry more than algebra and the other math that you've studied, geometry more than algebra lends itself, right, is more easy to kind of develop the idea of reasoning, especially logic, okay, and proving things to be true, not just kind of like presenting stuff and saying, here's some information, here's, I don't know, how do you solve an equation, that you actually prove like why that's true and stuff like that. And geometry lends itself to that. And so part of that proving process are these things called postulates, okay, which are you could call just like ground rules. Okay. And then these are statements that are assumed to be true without proof. Okay. You might also have heard the word axiom before, if you've done anything with like philosophy. Okay, as it turns out, at some point you can't prove everything to be true. At some point you just have to agree on a certain set of ground rules. You keep going back and seeing what proves the previous thing, you kind of like, well, you'll keep going. And so at some point you have to have sort of a ground set of rules where you agree, okay, we're going to say that this is true, and then if these are true, then we can build upon these things. And so then taking these postulates and definitions together, okay, we create theorems. Okay. And those theorems, those are new rules. Okay. So from these ground rules and our definitions, we then put these things together and reason out theorems or new rules. Okay. So you might take a certain postulation and kind of combine together in a logic way and say, oh, well, logical way, and say like, oh, well, if we have these rules and these terms, then oh, well, we can also say then this must also be true. If something up here is true, then something else is going to be true. Okay? And so a theorem is a statement proven by reasoning. Some already accepted statement. Okay, so like the classic theorem that you all know as the Pythagorean theorem, right? And that means that the Pythagorean theorem is proven from either previously proved theorems or other definitions. Okay, so the Pythagorean theorem is shown to be true using postulates definitions and other previously proved theorems and stuff like that. Okay, so that's kind of like a big picture of things that we're going to be doing in this class. All right, we're going to be kind of learning definitions and then putting them sometimes together to make up new theorems. Okay, sometimes proving them. All right, and if you've like heard of someone talking about geometry before and they're like, proofs, I hate proofs. Yeah. They can be a little bit different. They're a little rough sometimes, but again, we'll work through them. It won't be too bad, I don't think. It's just a different way of thinking than maybe you're used to in math class. All right, questions on any of that? All right, so then I want to get into some actual definitions and things here. So if I can move that away. Anyone still need this up? Can I move it? We're good. Okay. So let's take a look here then at some basic definitions. And I understand it might be kind of ridiculous to talk about some of these things, but we need them. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're going to do 3 columns here. I'm just going to divide the entire paper. So 3 columns, and I think 12 rows. 1, 2, 3, 4, 5, 6, 12. Yep. And of course, since you guys are writing in paper there, we can just kind of like add a line every time you need to, kind of thing. So definition, and then, or property. Description. And then Okay, so first column will be the term that we're going to be defining, and the second column is either going to be a definition or a description, right? Because I told you some of these things don't really have definition. We just kind of, they're undefined, so we're kind of describing as best we can, but they're kind of undefined. And then we'll have a little picture too, because that's what I love about geometry, is pretty much everything we do has a picture attached to it. Okay, so, all right. First one we're going to look at is a point. We're point, line, and plane first. Okay. So again, this is not so much a definition for a point. It's more like, you know, what some properties of that might be. Okay. So for example, one thing that we, you know, want to specify about a point, it has no side. Okay. No sides. No side. So if we think about a point as just like a dot, right? If I were to just like go on the board here and like make a dot, yes, we use this thing to represent a point, right? You know, if I draw that, you're like, oh, that's a point, right? But you know, we're kind of like assuming some things about that thing. Like if I were to, like, if you took a picture of this with your phones, for example, and you like zoomed in on it, right? That point would get much bigger as you zoomed in on it. Well, a true geometric point, if you zoom in on it, the shape and the size does not change. It stays a point no matter how much you zoom in on it, okay? So yes, me calling this a point when I draw it up on the board, we're going to use that thing as a point, right? But if you were to take a picture of your phone, zoom in on it, it'll get bigger and bigger and bigger, and technically that's not really making up a point anymore. So the idea of a point is it stays that way, no matter if you zoom in or zoom out, whatever kind of thing. Okay. The idea, one kind of concept about a point is it indicates a location. Okay, that's kind of another descriptive of it, at least you can think of. Okay, especially the coordinate plane, right? We'll be talking about geometry not just in like a normal plane, but also the coordinate plane, where the numbers attached to locations and things. Okay, and then here's the label it. Okay, typically when you label a point, it is with a capital letter. Okay, yes, you can name it with a lowercase letter, but traditionally it is a capital letter. Okay, so it's a capital letter name there. And again, I'll put that in quotations. That's in English, right? We read that as point A. Okay, I know this might be super basic. Again, I just want to make sure we're on the same page. We're speaking the same language here. Okay, so that was point. Next thing we're going to look at, line. Okay. In Euclidean geometry, lines straight. Lines straight. Okay, they do not curve. A line must be straight. Doesn't curve, bend, doesn't make a wave. Okay, gotta be straight. Okay. A line has no thickness. Okay, no thickness to it. And it is infinite in both directions. Both, and I'll put like opposite directions, right? Because they're going in exactly opposite directions. Okay, straight, no thickness, infinite in both directions. So the way we represent a line typically is something like this, and I'll put points there. Typically, you need 2 points to line. Typically, you need 2 points to name a line. So we have point A, right? Point A, there's a little point, represented with a capital A. Point, represented with a capital C. Okay. You need 2 points to name a line. You name it 2 different ways with the way this is written here. So you pick 2 points on the line, so I'll do C and A here, like that. Okay. And then you put a miniature line above it, like that. So that's the name. Okay. 2 letters name. This is also acceptable. So you can switch the letters around. Right? CA, line AC, they're talking about the same thing. 2 points on the line. Okay, and they're both going in the same direction. Please do include the arrows like that. Okay, so it needs to be, you know, the line with the arrows at either end. Because if you don't put those, that means something else. That later. What was that? Someone say it? No? Okay. Sorry, I thought someone said what the other thing was. Maybe they did. and they don't want to say it now because I called them out. All right. There's another way that you name a line using only a single letter. Okay. Another way you can name a line using a single letter is sometimes lines will be named with a single lowercase letter like this. Notice that M is a cursive M. M is not a point on. It's just like a label for the line. Okay? So you can also refer to this as line M, like that. It's another way to refer to it. Okay? So you'll see that as well. Okay? So either you pick 2 points on the line, name it, or you can give it a cursive letter like that and name it line M, or whatever other cursive letter you use, kind of thing. But those are your two options. Okay? Okay. So this is part of the challenge of geometry, is that we're kind of learning a new language. We want to make sure we're writing things. It's like new notation, right? You don't practice this so much in algebra. Got that here. All right. There's a plane. Right, a plane. And yes, it's spelled the same way as the thing with 2 wings that flies, but it's not that, obviously, right? So a plane is a flat surface, okay, 2-dimensional, you can think of it, 2D, okay? It has no thickness, though, okay? And it's infinite in all directions, 2-dimensionally speaking. Okay, infinite in all directions. This is probably the hardest one to draw just on a piece of paper. Okay, you can think of a plane as a piece of paper that is like has no thickness and extends forever. Right? You can think of this board, right, as a 2-dimensional plane. It's a finite 2-dimensional plane, right, because it's got edges and stuff. But if it were to extend forever, up and down, left and right kind of stuff, right, no thickness to it, but extend it forever, that'd be a plane too, right? The floor is kind of like a plane, okay, stuff like that. Kind of hard to represent, but again, the way we typically draw a plane is something like this, where you just kind of like draw some sort of quadrilateral shape, and you put little points or things inside it. You could fit a line inside there too if you wanted to. Okay. So you think of a plane as a 2-dimensional object. A line would be like a 1-dimensional object, and then a point, a 0-dimensional object. Okay. All right. The way you name this, you need 3-point plane. Okay. 3 points to name a plane. Okay. 2 letters for a line, 1 letter for a point, 3 letters for a plane. Okay. 2 points don't define a plane, right? 2 points don't define a plane. 2 points can only define a line. Okay. You have to have 3 points to define a plane. 3 non-collinear points, I guess, to define a plane. All right. Those are our basic ones right there. Any question on any of that? I know this might be super dry right now because you might think this is too easy. Maybe it is, but again, I just want to make sure we're all working on the same page. We've got a few more here. So we got line segment. Okay, a line segment, it's part of a line. It is finite. Finite, notice it's missing, it's not infinite, right? It's finite. It's missing the in in front of it, so it's finite. Okay, it has a starting point and a stopping point, and therefore it has a length, or also referred to as the measure. There's the metry part of geometry, right? Measurement. Okay. So a line segment is part of a line. So it's a finite part of a line. So one way to kind of denote a segment is that. Okay, FG. And the way we name this segment FG is again, 2 letters, starting point of the segment, stopping point of the segment, and then you draw a segment above it. You don't have to put a starting point and stopping point. You just draw the segment itself. Okay, you don't have to put a dot there. If you want to, that's fine. So if you put like a little dot here, a little dot there, that's fine. But that's the way you name it. Okay, that is the name, FG. Hidden within our previous diagram up here, there's a segment right here too, right? While we can talk about the picture as line CA, right, because it has arrows on each side, within this picture there's also a segment CA as well, right? That would be talking about the piece of the diagram right here. Okay? So yes, while we refer to the whole thing as line CA, there is a segment within it from C to A right there. We could call that, like, we could also name segment CA in there as well. Even though it's not the arrows, we can still say there's a segment there too. Okay? Alright. Other stuff here. Talk about this too. Tangent. Okay. You may have heard teachers, when they go off the topic or something like that in class, and they say, "Oh, we're going on a tangent. We need to go back to what we were talking about," and stuff like that. Similar kind of idea here. A tangent is a line that intersects a circle at exactly one point. Okay, a line that intersects a circle at exactly one point. That's a tangent. Okay. We'll do more with circles later. We're not going to use tangents too much right now, but I'm just throwing it in here. Okay. And so I'm going to do my best here to draw a circle. It's not bad. Okay. So a circle. Give it a center here. And so we can't just draw any line, right? We've got to be careful how we draw this line because we only want our line to intersect that circle at exactly one point, right? So if I were careless, if I just drew any old line, I'm like, oh, there's one point, but then I have to continue my line and extend through and hit there too. So like I couldn't draw a line right here. So I have to be careful with how we draw that line. And instead we want to draw it such a way that it looks like it just kind of comes down, kind of like touches the circle just barely at some point. So that's what my tangent might look like. It might just touch that circle just at one single point. Okay. We don't really want it to go through the circle because it goes through the circle, it means it's going to hit 2 points in the circle. That's a different thing. It's called a secant, and we'll talk about those later. All right. Oops. Oh well. I actually drew a line there, but that's okay. All right. Array. Array. Okay. Array, like a segment, is part of a line. Okay, array, like a segment, is a part of a line. Okay. It has an initial point and a point to the, I'm going to put these in quotes, left or right. Okay, and they might not be like exactly like left or right, but it's going to be, to another point. You're going to need 2 points to name array because it's part of a line. Okay. So here's what array would look like. Here's what array might look like. There's array. So you can see that it has an initial point and then a point to the left or the right. So that B starts at B, that's your initial point, and it goes through Q. And then continues on infinitely. Okay? So this is infinite in a single direction. Okay, infinite in a single direction. The way you name this, B, Q, and then you draw a array above it. Okay. Could I say this? Could I say QB? No? Why not?
Because B is the initial point.
Right. B is the initial point, right? Go through Q. If you say QB here, that means you're starting at Q, going through B, and then going infinitely through B, right? And that's not what's happening here. Right? We're not having a Q going through B going on forever. We're starting at B, going through Q. So here we cannot flip that order around, right? Now I didn't do it up here. What about for the segment? Could I say segment GF if I wanted to here? Would that be okay? Yeah, that would be okay. Yes, okay, it's talking about the same object. So I forgot to mention that up here. So here, okay, just flip it around. Right, for the line it was okay. Line CA was the same as line AC in the diagram. But here for the ray, you've got to watch your order. Okay, B is the initial point. Okay, think like a ray gun, right? You know, the ray gun, the start of the gun would be, right, and it shoots the ray out. And then it goes on forever, okay, until it hits something. Okay, and of course we can also have, you know, the rays don't always point left to right. You can have a ray that goes like this. Okay, so like this ray right here. And some students may be tempted to write this. And while I won't take points off for it, that's not how you typically write these things. So I would prefer that you didn't write this. Really, it should be N, your initial point, M, and then you draw the ray this way. Yes, I know the ray is pointing to the left, but normally you start with your initial point, and then your secondary point there, and you draw the ray above it. So anytime you're in a geometry book or something like that, you're going to see the rays always point, when you name them, the rays point to the right. Will I take points off if you do this? No, but I'll cringe. All right, so just make sure you do the right order there. Okay, I will cringe. Okay, all right, that was a ray. A few more here. Angle. Okay, of course we'll develop some more of these things too in the coming days as well. All right, an angle. The way we're going to define that, the way we'll define an angle, is two rays with a common endpoint. And I mean the common in the meaning of the word that it's shared, right? Oh, great. Thank you very much. Okay. I mean common in the way that it's like it's a shared endpoint, okay? Not common as like, oh, it's plain, it's like, you know, whatever kind of thing. It's not, it's common as in shared. Okay, like greatest common factor, greatest shared factor. And so, you know, for example, let's draw a ray this way. And we'll say there's like ray QP. And then we'll draw another ray going this way. Shared starting point there of Q, we'll say it's QR. And thus we've created an angle. Okay? Two rays, ray QP, ray QR, form that angle. Okay? Okay, ways to name an angle. This can get a little bit tricky here. You have a couple options, okay? Your safest way, the one where it's like going to work most of the time, is the three-letter name for the angle. Okay, this part right here of the angle is called the vertex, right? That's the pointy part of the angle. Okay, and so the three-letter name means you use all three letters there to name the angle. So we can call this angle PQR, or we can call it angle RQP. Okay, that is a safe way, probably one of the best ways to name it, is with the three letters. Okay, if you're ever unsure, that's a good default to fall back on. Okay, so that doesn't really look that good. Angle RQP, there you go. Alternatively, right, if we just refer to angle Q here, we could also just say angle Q. Because there's not really multiple angles here, I mean, technically, yeah, you could argue we've got like a small angle here, we have a big angle outside here, but typically it's understood that if you say angle Q, you mean the smaller one here, right? This little acute angle. Or if it's obtuse, it would be the same idea. Okay? This gigantic angle right here we kind of ignore. We'll consider it in other situations, but for the most part we kind of ignore that. So you can refer to it as a single angle Q. And then finally, other ways you can mention it, if you put like a number in there. No degree sign, right? So we're not saying this is a 1 degree angle, we're just putting the number 1 in there. You can also refer to this then as angle 1, like that. So you can also number the angles and put put angle 1 in there, like that to name it. So a couple of different ways to name it. The safest bet is going to be these three-letter names, but every once in a while you'll also see just a single name for the vertex. Notice it's just the vertex that we're naming there, or then again angle 1 if you number it. Okay. All right, moving on. Opposite rays. I'm going to run out of space here, so I'll have to put on another paper. Okay. And again, we won't normally do this much defining of stuff, but since we're today, we want to make sure we're on the same page. That's what we're doing here. Okay. So opposite rays. Two rays. Okay. That form a straight line. Okay. When I say opposite rays, I don't mean like they're kind of going in opposite directions from each other. I mean the rays are going in exactly opposite directions from each other. Right? So if I have, for example, a ray XR, okay, and then I go in the exact opposite direction using the same kind of starting point here. Okay, and I'll call that T. You can see that these two pairs of opposite rays form a straight line. Okay? So you could say, you know, XP and XR are opposite rays. XP and XR are opposite rays. They form a straight line. If you wanted to name this line, you have 3 letters to pick from, but you only need to pick 2, right? You only need 2 letters. So you could refer to this as line PX, you could refer to this as line XR, or you could refer to it as line PR, right? Any 2 of those 3 letters, since they're all in the same line, means they're collinear, right? They share the same line. Any 3 of those letters would also name the line, too. Okay. Likewise, we also have some segments in here, right? PX, XR, and PR are also segments you can name, too. All right. Since this thing here is made up of 2 rays that share a common vertex, that means it's also an angle, right? PXR, ray XP, ray XR, it's an angle. What's the measure of that angle?
180 degrees.
180 degrees, that's right. Straight lines, right? Or you can also think of them as 180-degree angles. That's right. Okay. Also known as a straight angle. Straight angle. And again, we'll see more about that. All right, 3 more here, and then we're done. 3 more, then we're done. You guys are doing a good job. First day, and I'm throwing all this junk at you here. You probably all still be asleep by now. Okay. All right. Continuing on here. So again, we're doing term, definition, sure. Just some definitions and terms here. Okay, segment, bisector. Another thing I love about mathematics is that you don't have to do a whole lot of guessing sometimes when it comes to the terms mean. I mean, we know what a segment is. Okay, the prefix bi means what? 2, right? And then sector, right? So sector is like section. You're cutting into 2 equal sections. So a segment bisector is something that cuts a segment into 2 sections or 2 equal sections specifically here. Okay, so segment bisector is a ray, line, or segment that divides a segment into 2 equal parts. Okay. So a segment bisector is something that cuts a segment into 2 equal parts. A ray can do that, a line can do that, a segment can do that, a point can even do that, I would guess, you know, kind of thing. So as an example, start with a segment. Okay. And let's draw just this like line here that goes through it there. For example, we could say here that line N is a segment bisector of segment AC. Okay. Now, in geometry, right, we're going to use a lot of like visual diagrams, pictures and stuff like that to kind of like do work and to figure things out and stuff. We want to be careful, right? We can't always trust our eyes, and we want to be sure that we know that something is true. And so here I drew this line N. And you guys, you're like, yeah, it looks about halfway between A and C, right? It looks about halfway. But we want to be sure, and the only way we can really be sure is to have some markings given to us, right? I mean, I guess one way we could do is measure it, but even measuring it, we could be off. If we put markings in here, and see these little like tick marks here, okay? Those are called congruence markings, and you can see more of those as you kind of go through class. But this is basically saying that this part AB here is the same as this part BC. Okay? So there we go. All right. Questions on any of that? All right. Let's see here. All right, we're going to do collinear and coplanar. Okay. So collinear, we call things collinear. Well, again, co means to share, linear means line. So it's points that lie on the same line. Okay? And then coplanar, those are points that lie on the same plane. Okay? So a picture, for example, for this, I'll draw two intersecting lines here and label some points. Okay. So from this diagram right here, what are some examples of some collinear points? What points on the same line here? Go ahead. C, T, and can you name one more? A, yeah, C-A-T, cat. And sometimes they spell out cute little things there. Are collinear. Okay, and let's see here. Avery, did you have another example you could give me?
Yeah, B-A and R.
B-A-R. Okay, also are collinear. Very good. Just some examples there. And again, sometimes they spell cute things. Or they have little cute spellings there. Okay. Now here in the next diagram, we have to be careful, right? So coplanar, points that lie on the same plane. I try to draw a three-dimensional object. Maybe you could call it like a cube, rectangle, or something like that. Alright, well, we'll stop there and we'll finish up. I guess I didn't get you to go do the homework, so that'll be okay. We'll just get your syllabus signed, and that's what we'll say is the homework then, okay? Sorry we ran out of time there. Have a good day, folks.
All right.
Thank you. Pretty much like in the back row, in the back two rows. Emmanuel, you are right there. right there. Jalen's right here. Preston. Emmanuel, I'm not going to make you fill out another one. Just for now. Alright, let's see here. Kaden here. Let's see here. Laura right here.
Oh, no, you're fine.
So everyone, just if you could find your papers here, and I can help you find them too if you're Does anyone need help finding their seat? Sorry again? Right back here. Anyone need help finding a seat? Sorry, what's the name? Trinity. Okay, I got you. You're right. See that LPP is right there? Did you, so I think they have least you have for like the old.
Yeah, I don't know.
Okay, I might be able to look that up for you. Okay, no signal. That's a good start.